Hey kids, Mark Miller here. My son Campbell. Campbell, how you doing, buddy?
I'm doing pretty good. I had a great breakfast.
Yeah? I saw you making it. Saw you cleaning up afterwards. You got gum in your mouth, my friend?
Yeah.
You got your space t-shirt on?
Yes.
Excellent. Well, glad to hear all of that. I think we're going to skip the what happened last time because I don't remember exactly what we did, and we're going to do something new this time anyway.
Yes.
Let's talk about what I want to do. Is that cool? I created a new instance of PowerPoint, and looks like your mouse might be on my machine.
Oh, okay. Here. It's off.
Thanks. And I kind of want to talk about this new project, and I guess we'll call it SuperCalc. It's basically a, I don't know, we're going to try and improve the calculator. How can we do that, you ask? Well, we can add units, right, such as meters, seconds, etc., to a number. And if we have units in a number, then that means we can calculate the right units for an answer. And if we know the right units for an answer, that also means we know what dimension an answer is in. Right? Is it first, second, or third? For example, if we're talking about a unit that measures distance, right?
Mm-hmm.
Units, if the answer units are a distance, right? And I'm going to even say etc. on here, like that. Maybe to get everything to fit on one line, I'll do this. Units are distance. Okay. That's one way that we can improve the calculator. A second way is we can support fractions. You know, both improper and proper. If we're supporting a fraction, then we have this idea of the top units and the bottom units.
Yeah.
And, you know, I don't know if you've experienced yet any of the math you've worked on, but sometimes your answers can be like in meters, you know, seconds, kilograms, or something like that.
Yeah.
There, on the top, you can have, you know, 3 different units is what you can have, for example. And on the bottom, you might have, you know, something on the bottom as well, right? You could have like meters squared, or whatever, right? Meters cubed, right? So this idea of units, right? What do we have on the top and bottom? This applies to any number.
Yeah.
Yeah. So maybe instead of, you know, going off the fractions, it's most obvious. 55, like in the United States, there's a speed limit sign that's common that says like 55 miles per hour, and that means 1 hour, right? At the bottom. So there we go. We've got top units, bottom units. This is a list. Bottom unit is also a list. And the only question though is that I have that I'm not sure about is that do we have m in there 3 times because it's cubed, or do we have m and then the cubed symbol? You know, m to the 3rd, like that. Do we store it in a more efficient way? I'm not sure yet. I'm leaning towards this because especially if we have m to the 2000th power, then we want to store it just at 1M and the number 2000 as opposed to 2000 M's
That's
being
true.
in the list. So that's probably how we're going to store it, something like that. So that's kind of what we want to do. So I want to kind of go through the process of creating this. Our strategy is going to be to create, we need 3 projects. We need one for our UI, our user interface. We need one for our logic, like our math logic.
Yeah.
Right, and also to hold our units logic and our fraction logic, so we'll be able to support that, and our regular a regular number. But we'll talk about that in a second. And then the third piece we need is our test project, because we're creating a calculator, it can't be wrong, right? Being wrong would be really bad. Does that make sense?
Yeah.
And when you're in a situation when being wrong would have consequences, the answer is always a test project. Does that make sense?
Yes.
We're going to throw a test project, or maybe we're going to release this and this will be a project, something that we release. Well, we are going to run test cases before we're going to want to run test cases before every major update and release to make sure we haven't broken anything. Does that make sense?
Yeah.
And if a customer reports a bug, we're going to fix the bug, but we're also going to add a new test case so that the test case can tell us if the bug ever comes back.
Yes.
Okay? So those are the 3 projects. So that's our strategy. 1, 2, 3. With regards to numbers, let's just talk about numbers for a second. We have a couple ways of representing numbers, right? We have, kind of this decimal, right? 1.54. You've got percentages. We've seen that before. But I would argue, in this case, the percent could be called a unit. Maybe. Or maybe it's something we just understand. We just understand really well.
I don't know. I feel like,
And then we have an option, if we understand really well, we have an option to show results in percent format.
in percentages, yeah.
Yeah, percent format, decimal, or even maybe fraction. Okay. Right. The other thing that's kind of interesting is if we look at like a fairly complex number that you can deal with in a problem, it looks kind of like this. It's like 2. Hold on. I want to kind of draw this out graphically. Put a 2 here. Drag this down here. Make that a 3 down there. And then we have the units, right? So this will be, we'll get a line between these 2. Like that. So it's like 2/3. And then there's some units in here. In fact, actually a better example of this is like this over here, like 1 2/3. Right? That's an example. This is an example of a number I'd like to be able to represent in our calculator visually.
Yeah.
Does that make sense? I want to be able to type in 1 space 2 div 3, 2 divided by 3, and see this. That would be awesome. And even cooler, what'd you say?
It would.
And even cooler would be to have this divided by another fraction down here, and to see it like that. Wouldn't that be cool? I would be like, that'd be a better calculator. So we could type in pieces, for example. I don't know, what are you thinking?
I don't know. I feel like that seems like maybe we do it.
We call that jumping the shark, where it refers to an old TV show in the United States called Happy Days, where in one of the episodes, one of the lead characters jumped off a shark or something like that, and it was apparently so bad that everybody stopped watching the show. And it's sort of the jump the shark moment, and it's like I do this all the time. I think where basically I do something so crazy, everybody's like, no, that's the line. So that's my jump the shark moment here. So maybe we won't do this, but maybe we will do this. We'll do the one on top. You cool with that?
Yeah, the one on top for sure.
All right, cool. And then we could do that. Let me ask you this. What's that divide symbol? I wonder what I don't know what the divide symbol, I don't know how to get the divide symbol. Whatever that divide symbol is with the two dots above and below, would you prefer that? There?
No.
What?
I would not.
You would not. Would you prefer a slash to indicate divide?
I think maybe just
Like that? And then we put this one over here. Like that? Is that your preferred way of doing it?
Yeah.
It is? Okay. Well, the cool thing about this is it's fast and easy to type in. Right? It is 1 space 2 div 3.
Yeah, but I think that for fractions, it should be a different division symbol than when we type it in for calculating.
Like, that's kind of what we're doing.
Yeah, I like the over symbol and then
the
slash.
Realize though that this is a fraction, right? This piece is a fraction right here. Does that make sense what I'm saying?
Oh, that's true. I guess though maybe it's just we make the symbol different for something, for a situation like this, or when we're calculating.
Well, let's wait till we get to there, and we won't make a decision on it yet. Is that cool? I agree that we should put thought into the decision, but this is a decision we don't have to make right now. And this is actually one of the things I do all the time is I'm like, I'm often juggling, where is the decision point? Where are we making the decision? When do we need to make it? And I'm pushing things up as far as I can.
Yeah.
If we go back up to this example up at the top here, which is 1.54, well, we know that 54 is 54 100ths, which is equal to, I believe, 27 50ths. Right?
Yeah.
So all three of these are ways of representing the same number.
Yeah.
Make sense?
Wait.
Did you say yes?
Can you move that up a bit?
What'd you say?
Can you move that up a bit so that it's visible?
Oh, you bet. There you go. So these three are all the same.
Yes.
Okay. So now, how do we represent the number? This is like kind of the question. And how are we going to programmatically represent that number? Because I want essentially one entity to be able to give me this, or this, or this. How do we represent a number? How do we store a number? And this, I think, deserves some thought. And I think that I think there might be an enum that we create that says whether it's a decimal or a fraction. And if it's a decimal, then we have a property for that inside the number, our new number class. We'll call it the SuperNumber. And that just holds the entire decimal value, right? In a decimal, which is the biggest number we can have for the most precision. Because we want precision because it's a calculator.
Yeah.
Okay? The fraction, I think we need a couple values. We need like the whole number, which could be 0 for proper fraction. Or sorry, 0 for an improper fraction. For an improper fraction, right? You know what I mean by that? If we have like 47 or 49, 47 ninths, for example.
Yeah.
That's an improper fraction, right? But 0, we could have it be 0. It's going to have the numerator, and it's going to have the denominator.
Yes.
The denominator is going to also need to have units.
Wait. Yeah.
And the whole number and the numerator are very closely related to each other. They're together, I think, going to share some units. So we got to put units somewhere, but they don't both need units.
Okay.
Right, does that make sense? In other words, if I have 1 2/3, and where am I going to, and it's meters per second, does the 1 or the 2 get the meters unit? It's really the whole thing.
The 2.
Yeah, so I think what it really,
Wait, maybe we say the units in that situation is just for the whole thing, meters per second.
That's interesting. I'm kind of, well, I don't know. I'm thinking the enum. So the enum determines the type of number and storage that we're using. It just occurred to me that the number itself can have units.
Oh.
And actually, you know what? I'm totally taking your. I'm going to do it. We're going to have basically. There's 2 sets of units, 2 kinds of units. Units we multiply by, right? In other words, the main units and units that we divide by. Does that make sense? Every number has those 2 units, and I think that's how we'll store it. Okay, so first thing to do. Let's go. Let's switch over to your machine.
Yes.
We've got SuperCalc out here right now. We just created. Can you go to GitHub? Show this. Copy that to the clipboard.
Yes. So.
Where is it? That one right there. I'll copy it to the clipboard. I'll put that in the chat room. So kids over here watching this, you want to get this. You can go grab that now. Now that right now only has one, the one project in it, just the WPF. Let's say we want to add 2 more projects to this, Campbell. We want to add a unit test project. Type in unit or test. Type in unit test probably. We don't want the end unit one because it's .NET Core. We want to get .NET Framework.
Here?
Unit test project C# .NET Framework. Pick that one. Create a new project. That's our unit test project. Call this SuperCalc test or math tests, something like that. Number tests, something like that. SuperCalc tests. Tests. Put an S on that. We're going to put at least 2 in there. Okay, great. And then let's also create. I'm going to create a library that's going to contain our low-level logic. So right now we've got our WPF, the SuperCalc app, right up there at the top.
Yeah.
That's got going to have our UI. We don't have any UI in there yet. All right. So now we're going to create a library. Type in library here. There you go. Not standard. We want .NET Framework right above your head, right where I'm pointing. That's it. Class library .NET Framework. Okay. And this we'll call SuperCalc Core. I like using the word core, C-O-R-E, to indicate that it's kind of a central, fundamental, important part of the application. Just great there. All right.
Because just writing SuperCalc fundamental important thing.
Yeah.
Fit.
Do me a favor. Hit Control-Shift-S. That's going to save everything. Oh, is that a shortcut for bringing this up? It might be. There's a button right there. Does that. Yeah, that's it right there. Now that you've saved everything, let's go check it in real quick, just so people can get that. And we're just going to say, oh, wait, we should see more than just SuperCalc Prep Solution. Did it put it in the wrong place? It did. It put these 2 projects in the wrong place. I want to put them in a different place so that we...
It put them in SuperCalc. Did it?
Now, look what it did. If we come in here, we say Open Folder, File Explorer. Let's see. Yeah, SuperCalc Core and Test are both in the wrong place. So what I want to do is I'm going to do this. I'm going to remove that and remove this. I want to put them inside the folder SuperCalc. So I'm going to take these here, drag them in here. And then I want to come over here and I want to say Add Existing. projects. We're going to add the two I just dragged in here.
Yeah.
I think we're here. No, where are we? What's our folder? Hold on.
It's in Documents SuperCat,
I'm going
right?
to open this. Yeah, it's over there in Documents. Just copy that. And then we're going to come back over here and say add existing project. Paste that here. And then there we go. There's our core project. And we're going to come back in here, add existing project, and there's our tests. Okay? Now we're going to save everything. I just need Control-Shift-S. And now we come back over here, we should see the other projects. There we go. So now we can say just, step 2 is we've added a library and a unit test project. Still no code has been written. We're just building the structures, right?
Yeah.
Switch back, camera tucks that in, switch back over to my machine over here. Take a look at this, just getting this in my head here, how we're going to do this. Yeah, we'll have, I think, 2 different kinds of storage. One of the tricky risks, the problems of this, that I'm slightly worried about, is what happens if we're in one format and we need to go to another, or we need to multiply two numbers that are in mixed formats. For example, I've got one in decimal and one in fraction. Should I
Like
always,
what? Like what?
What if you type in 1.5 times 2 1/3?
Oh.
Do I want the answer in a fraction? Do I keep everything in a fraction the whole time? Which is something to consider. It's something to consider.
I think in that case we should convert the second number to the format of the first, I guess.
So the
if you
format
have
of the first.
a decimal times
determines.
a fraction, you convert the fraction into a decimal. Maybe.
Okay.
Maybe.
Sure, maybe. I don't know. Let's give it some thoughts and come up with a good answer, whatever it is. Let's switch back over to Visual Studio now.
We could also do it the other way around, and then this we convert the first number into the format for the second.
Right. One of the things I liked about the one of the projects we created in the past, Campbell, was we made we did that Khan Academy solver where we could ask it a question and it just knew the units you wanted. And
maybe
solved it based on that. I like that kind of smart inference.
Ooh. Maybe we can make it so that it tries to guess your number, to guess what units you want it in or format you want it in, and if that's wrong, you can change the format that it is in. So if it gives you a decimal but you want a fraction, you can change it to fraction.
Right. Or let's say I type in 2 fractions with units. It could do a divide, one divided by the other, and show me how many of one fraction goes in the other fraction. Right?
Yeah.
Which is totally what Khan Academy questions are asking you. Let's go back to Visual Studio. And so what we want to do is we want to go to SuperCalc Core and we want to start creating our number. Got that class 1 in there. Double click on class 1 down there. Go ahead and delete class 1, I think.
Here or?
The whole thing. You want to get from public all the way to the end brace. I think. Just to the end. That one right there, right? And we want to create a new class here, I think. I guess we'll call it our SuperNumber. Is what I think we'll do. I just want to back up. I want to get the backspace off my mouse. I want to back up one right there. All right. Type in C for class and hit the space bar. And now let's call it SuperNumber, I think. You want to do that?
Sure.
Okay, good. Hit enter. Go up 2 lines to an empty, go up to end of line 8, hit enter to get down to an empty line. Use the letter E for enum. Have you ever created an enum before?
I think so.
Okay, so we're going to call this enum number type, I think. Or number kind. One of the two, whatever you like best.
I think type. Oops.
Okay. And then hit enter once you've got that. And now you're going to say decimal.
And then
hit enter after you're done typing decimal. Hit enter.
And then here we
fraction.
have fraction.
Yeah. And now
percentage.
hit semicolon. Semicolon stops this whole thing. Get you out. Sweet. All right. So.
Wait, not percentage?
I don't think so. I don't think so, because number type is going to refer to how we're storing the number, and for percentages, we'll still hold it as a decimal, right? I think percentage is somewhere else. Go copy number type to the clipboard. Just click on it, hit Control-C, there you go. Now come down to line 17, and let's create a new property of number type. So we want it to be an auto-implemented property, so that means you're going to use the letter A for auto-implemented property. You can use what's on the clipboard, which means you can use the slash key right underneath the backspace. The one under the backspace.
Oh, so backslash.
Yeah. And then hit spacebar. And now we're going to call this, I think, kind. SuperNumber kinds. Type. Maybe type. Maybe type. I'll take either one.
Oh, wait. Right?
No, it's public property, so I make it uppercase. Okay. Good. Now, we need to store, there's basically a couple different storage pieces right here. One of the storage pieces that we need is a decimal. So type in A and then DE. A for auto-implemented property and then DE for decimal in space. And now call this value. Should we call it value? Maybe value. Hit enter. Okay, good. Go down to the next line, empty line. Give me a new empty line after this. Now we're going to do, I think we're next working with integers. So I do AI, yeah. And we're going to say whole number. I'm just looking at our spec. I'll switch over so you can see where my eyes are. My eyes are looking right up there. We're inside the data types we're going to use for this. So I think we're going to do a whole number. And you know what? I think I'm going to change it, Campbell. I think I'm going to change that type to a decimal. Go up and select that int. Double click on int. So you select just that. And now type in TDE. T for type and DE for decimal. Good. All right. Shift enter on this line too. I think I'm going to make all these decimals, I've decided. This one is going to be numerator. What'd you say?
Why would a whole number be a decimal?
No, you've asked me questions like that, I'm going to change it back. Change this one to, say, numerator, though. I'll change it back. Fine. It's not hard to change it back and forth. I'm just thinking about, like, what happens if somebody says 2.5 over 3, right? I guess that's not a fraction, that's just a divide operation. All right, we'll change them to ends. And then shift enter here and give me a denominator at the bottom of this.
Enter.
Now, there's a cool feature in Visual Studio called rectangular selection.
I remember it. It's like
so
Alt-Enter.
So I want you to rectangularly select those 3 decimals, and we're going to change them to ends. So Alt, and then move the arrow keys with the Shift key, I think. Try that. See if that works.
Nope. And then int.
I want only the last 3. Whole number, numerator, and denominator.
Dang it. Wait, sorry.
So, there you go. Type in int now. INT. Okay, good.
No.
Just hit Control-Z. There you go. Okay, that's not bad. Now I want to give it 2 different constructors. One that takes a decimal and one that takes 3 ints. Okay? So we can construct it in 2 different ways. And if we construct it with 3 ints, we know that the number type is what?
It's an int, right?
No, if I construct it with 3 ints, what's the number type? You got 2 choices there on lines 11 and 12.
Oh. It would be a, right?
No, if I construct it with 3 ints, 1, 2, and 3, what are these 3 components of? Are they of a decimal or fraction?
Oh, they're of a fraction.
Right, that's kind of what I'm getting at. So here's what I want you to do. Go down after line 22, hit enter, and there's a CodeRush template called CC for Create Constructor. Right over here. Hit enter there to get down in the next line. CC. And now here, go ahead and toggle the spacebar to select all. But now go down and get rid of type and value. Spacebar again here and down there, spacebar. Good. So now you're just passing a denominator, numerator, denominator, and whole number. Hit enter. And look what it builds for you.
Ooh.
It gives you a constructor that takes 3 parameters, right? Whole number, numerator, denominator, and then assigns them. See what it's doing?
Yeah.
Now we just said, you just hit enter on for all these if you want, or control enter if you want to accept them all. Now we said that this, you have to be, it looks like the caret's not on these other pieces. You have to be on them for that to work. Oh, controller didn't do it. Okay. I thought it did. All right, so right here we know the type of this is what? If I'm passing in 3 of these.
We know that it's a fraction.
So can you set the type property that we declared on line 22? You see it up above. So type is equal to, wait, look what it was suggesting. No, it's not here anymore. Hit backspace in the space. Try it, see if it gets it again. There you go, look. Number type, dot.
Yeah.
And then enter. There you go, semicolon. Okay, I want you to now create another constructor that takes only the decimal in and sets the type to a number type dot decimal.
Okay.
This one you only need 1 number, so select all maybe is not the helpful one this time.
Just value, right?
Agreed. Good. Scroll up a little bit so we can see it. Just, there you go. Cool. And now, see it's down 1, suggested right there.
Oops. No, sorry. What am I doing? Oh, semicolon.
Cool.
So now we know when it's a decimal or when it's a fraction.
Right. I want to change something. So we've learned about, let me come over here and talk to you about something. We've learned about, we don't really talk about properties a lot, I think. Have we talked about properties? Do you have a sense of what a property is?
Yeah, I think so. Right? It's basically like a local variable for just one method.
Right, it is. One of the things, hold on a second, I'm just switching over to my machine here. I wanted to bring up controls for your camera. You're a little bit out of focus there. You might bring your hand to the, there you go, that I think it helped out. Sweet. Yeah, there's storage, right? It's like a variable, is what it is. There you go. Got crystal clear focus. See how long that lasts. It's like storage. You see the getter and the set keyword? That means, because it's immediately followed by a semicolon, means, hey, you know what? Visual Studio. Surely does.
Surely does. He's in the house.
He's asking, did you miss me?
Yes.
Mark, you better clean up this code. Surly Dev's in the house. That's what Code Rush says. Welcome, Surly. Yeah, we missed you. How you doing, buddy? It's good to have you back. Maybe you can fly some drones for us today. Give us a drone check. The getter center means what happens is Visual Studio is just going to have some secret storage in the background that's going to store it for you in a variable called like underscore value or something like that that nobody ever sees. Back in the UK, says Surly Dev. Surly Dev has spent some time in Germany.
So it's like a private variable, but for Visual Studio. So it's like...
Kind of, yeah. It's really the C# compiler does this for you. It's not Visual Studio, to be fair. Yeah, here come the drones. Yeah, so what I want to do, though, is I want to use a Code Rush refactoring up here. I want to change this. I want value to be smarter. In other words, if value, I want it to create a backend store for it. It's going to be a variable called value. But if I want it to check what type it is, and if its type is a fraction, I want it to figure out what value should be and calculate it, and then return it. Does that make sense? So watch this. I'm going to say convert to property with backing field. I've done that right there. And now it's given me these two things, getter and a setter, right? Which is basically just saying my setter does this, and my getter is just going to return this. That's what this basically means. Hey, whatever the result of this is, just return it. Okay. But what I want to do really in my getters, I want to do another check in here. That's what I want to do. So I'm going to choose expand accessor, which will turn it to this, so I can add more code. And I want to come in here and I want to say, hey, if type is equal to number type dot fraction, then I want to say value field is equal to, and can you guess what I'm going to write here?
Just
why would I care if it's
value, right?
What
or
is
no?
I'll give you a hint. That's your hint.
Oh,
What do I write there?
fraction then, right? Or
Yeah, see if you can write it. What would you write there?
oh,
Value field is a decimal. It's the actual value, right? If I want to see, if I say that I have a fraction that's 1.5, and then I ask what is its value, what I'm getting at is I want
you need
this
fraction.
plus something else. What do I want?
Value, right?
Close.
Or
I want to calculate it. Look what I'm typing in. See if you can see guess how it ends.
oh, numerator over denominator. We're getting the format for the fraction.
Yeah, I'm basically calculating it. I'm saying, hey, if the number type is a fraction, then I'm going to go get these other pieces. All right?
Okay.
Cool with that? That's all I'm doing in value. So now value's got a setter, which I can assign it, but it's also got a getter, which will always give me a value. Now, what's cool about this, watch this. I'm going to come here, rename file to match type, because right now we're in this class 1. Class 1, see that? That's not going to do us any good. Well, it looks like maybe I hit something different. That's okay. We'll do it here with this one. I choose a move type to file. So we're going to rename file to match type. Cool. So now I've got two types here. Number type, two classes. Number type that is an enum and SuperNumber. Good?
Yeah.
Okay, let's go get our tests. We're going to add a reference. So right-clicking here, choosing add reference. I'll let you do it. Right-click on references, choose add reference. And in the project, we're going to add a reference to the core. Yeah, click it. Wait, go back up.
Oh.
You've got to get a checkbox right there. Yeah, it's not my favorite UI. It's a little tricky to understand it. Go ahead and click OK now. You're good. Good. Now we've added a reference to the core. Now over in unit test, let's go down to unit test. Double click on unit test 1.cs. Yeah, there you go. And we've got a test method here. We need to add a using statement up here. We need to use, so go ahead and go down to line 2 and then hit Shift Enter to duplicate that. And then we're going to type in supercal core, I think. And we should look for IntelliSense to suggest it. Not the tests. Hold on, let's double click to make sure the namespace is right. I thought the namespace was supercal core. That's the namespace. That's what we want to use. Interesting, it's not suggesting it. Go ahead and paste that in. Good, enter. Let's go down inside our test method 1.
Okay.
And I want to create a new, so type in new, space, SuperNumber. The SuperNumber. I wasn't suggesting it. Type in ERN. What? Hold on. I want to go back over to. Why don't you see it? Oops, double click here. It's public. Is it just not been compiled yet? This is really weird. Okay, come back over to the test. New SuperNumber? Really? No suggestions? And why aren't you working? What's going on? I do see some things here that I'm slightly concerned about. The references. References NuGet and packages that are missing. Okay. So I'm right-clicking this, manage NuGet packages, and is this my problem? This is what's installed. What are we missing? Let's click the link. SuperCalc packages. What's really weird is it's looking like over there.
What?
That's what it seems to me. It's in a weird place. Test adapter props. I wonder if it's an update related thing. Let me try updating. Try updating this one as well, so we get any better results by updating both of these. What's interesting is it says the missing file is SuperCalc packages. Yeah, I don't understand that. I really do not understand that. Did you just drop the volume down on the Kimball, on the boot box?
No.
I wonder if Shirley was able to do that from another folder, from another chat room, I mean. Is this what we opened up? Project Manager settings, tools, media paragraph. Select both options under package restore. Okay, let's go see those options, see if we have those. Tools, options, media package manager. We have both those options. They're already checked.
Well, why isn't it? Okay. And why did it have that as the missing file?
We did move the project files. Is that those? That's, okay, maybe that's. It should relatively though. The project files that we had should all still be good. Okay, I think I understand. It's because we moved this guy. Is what I think happened. Let's try unloading this a second. If I unload the project, it'll open up the actual text of the project file, so we can edit that text. We can look through it. They were saying edit the file directly to update the package references. So let's look and see if we can find the packages in here. Okay, here we go. Import project, packages. All right, let's. This one still says. I'm going to bet it's that is my problem. That's still showing a 2.1 version. Let's see if that reload fixes it. Did not look like that fixed it at all. says it's using 2.23 on both of these. Let's rebuild do for us anything. And this one in there, let's go in and unload the project again. Wow, I can't see it right there. Oh, I missed that. Is that it? Let's see what else we've got. This one. This one, they're all over the place. Yeah, so moving that test project, better to have just deleted it. That's the lesson I've learned from this. Super cup right there. And super cup right there. I think we have some versioning issues that are going to be problematic. We've got 2 1s and 2 3s in here. I'm hoping that Visual Studio will be smart enough to solve that for us. Let's see, any others that we missed? Okay, I think that's it. We've gone full all the way around. Close it down. Reload the project. How much trouble are we in? Missing file is packages, MS test 2.1. 2.1 I don't really want anymore. So we kind of replace it with 2.3. We don't see it in here. I'm gonna go in, I'm trying to do like a couple more tries on this. And then I'm gonna, yeah, since look at this here, see this right here? See that name and this name are the same? It's the same piece. I'm gonna kill that 2.1 is what I'm gonna do. And then let's go find the other 2.21 as well. 2.1, here we go. Same thing here where we have props and targets, and right below it we have props and targets as well. I'm going to get rid of these
which is not what we
2
want.
for the 2.1s. And then we should have one more right here. That one, get rid of that one. Let's try saving that. I think we're going to be lucky this time. That's what we're talking about. What do we get? Okay, cool.
Oh.
We got a warning here now that says what? Using the type, wait, what is the problem? Conflicts with imported type SuperNumber, SuperCalc core. SuperCalc tests. Wait, what? Where are you getting that from? Again, I think this has to do with, we've only got one SuperNumber in here, right? No, it looks like we have 2. SuperCalc core is there. No, wait. It's funny, I do this and I try to get the one to test. It does not put me in tests. Oh wait, here it is, look at this. See that?
Yeah.
You see that?
Oh.
Okay, hold on. How is, yeah, the move was a bad idea. It's had a lot of consequences to it. Well, I thought the move was a good idea, but it has a lot of consequences to it that I'm starting to learn here. I'm not feeling so good about. Next time, definitely I won't move the project like that. SuperCalc core has got a SuperNumber in it. Let's open folder and file explorer. This one's got a SuperNumber in it too. I think what we somehow dragged it down here into 2 different places. That's what I think we did. Okay, let's just double check the 2 of them here. Just make sure we've got We didn't have any changes in one that we thought should have been in the other. All right, so here's our super number. Okay, got that. That's what we just built. Let's do this one. Look at this. Yeah, they're both the same. So I'm going to take this and delete this from here. Not sure how it got there. Okay, cool. Now, back over here. Now our errors are gone, I think. Now we can do a build of everything. All three succeeded. Sweet. Okay, now we created a super number. We're going to create a test for this. So I'm going to do this. I'm going to say, hey, super number. Oh wait, I want to create a super number that's 1.5. Can you add the right parameters here to make it be 1.5?
Maybe.
Well, let's start with some tooltips. Control-Shift-Space brings up tooltips to tell you what parameters that you can put in. That means it's got how many constructors?
Oh.
How many constructors does it have?
3.
3.
And so the whole number. Wait a minute. Yeah. So here we just do. Oops, caps lock.
Nope, there's a little bit of confusion here. When I'm passing a parameter, I don't need to declare its type, ever. I only declare types on variables and parameters, but these are like arguments right here. That's perfect. Perfect. 1.5. Now, I want to make sure that this is equal to 1.5. So I'm going to say assert equal 1.5 super number dot value.
Yes.
And that's my test. Right?
Yeah.
That's going to test it. Can we run that test? Let's see if it works. Nope, that's going to start the program.
Oops.
Not the test. Let's go start the test, kids.
Oops,
There you go.
Uh-oh.
It expected 1.5, but got 1. All right, let's go take a look at it.
Is it because we have the wrong,
Something's wrong with the code. That's my take on it. If type is equal to fraction, then value field is equal to whole number plus numerator divided by denominator. These are integers. And integers, we need to cast these to a double, I think is what we need to do. Or a decimal, I mean. Can we do that? Let's see if we can do that. Let's see if that changes it, the test results. If it does, then we know it has to do with what C# is doing when I have one int divided by another int. It wants to give me the answer as an int. Does that make sense?
Yeah.
So I think that's what's happening. Let's go back over to unit test, try running it one more time with that change. Because the logic is right. Okay, so this is interesting.
It
says it failed,
double,
but the values match.
but it expected a double, but it got a decimal.
Yeah, now this defaults to a double. I can come in here and I can give it an M to make it a decimal. M is the abbreviation for decimal. Let's try that. And it generally means money, I think, is what it means. There you go.
Okay.
Finally. Okay, cool. Can you create something for 1 3/4 or 5 3/4 or something like that?
Yeah.
And give me a give me a test for that. So AE gives you the R equals. Wait. No, because this will break. Stop. That's going to break this. This test will break. I want a new test, is what I want. So I was going to say, let's copy this to the clipboard.
Or just shift enter it.
Come bring it down here. Yeah, that's going to be super number 2. Now change this one down here.
5 3/4.
Sure,
you said?
whatever. Just give me something different. We can't really test. We can't effectively test irrational numbers like. Is that right? 1/3 is an irrational number because it goes on and on and on. Is that right or no? No, irrational means I can't represent it in a fraction. but we can't test numbers that go on and on and on, like a 1/3. Okay, good. That passed as well. Excellent. So, so that's cool. We can now declare our super number, and we can see if it's, we can see what its values are. Do you want to test adding fractions together?
I don't think it will work yet.
No, but do you want to work on that? Do you want to
Yeah.
build fraction addition next?
Yeah.
Okay, so let's do this. Let's change this to, let's rename this to test fraction to decimal conversion. And I think I want to see what happens when I come in here. Let's give us a third one. I want to do a 1/3. So 1/3 we would write like this.
Oh.
Right? And so I want to see if I can get 0.3, like this. If this is going to say it's matches or not. I think it's probably going to say it doesn't match, because I think it's going to have greater precision. Yeah, see, look at this.
That's a problem then.
Let me copy those and let's add them and see what happens. Wouldn't that be cool if we could get this test case to pass?
Maybe. Oh, maybe.
Ha!
Yes.
That's all we need. We need that many digits to make it pass.
Okay.
So that's sweet. All right, cool. So we can actually do tests, right? We're getting to a number that's so small out here, right? Every time we go out, it's 10 times smaller.
It barely affects it.
Yeah.
That last 3, it's not even impacting the number in a significant way enough so that it would affect.
Yeah.
Yeah.
Okay, cool. So we got that. Let's create a new test case out here.
Like if you were to mark that number and have it go up each time you change the value to higher, that last 3 when you added it, we wouldn't be able to perceive it as
Right. Right.
Okay. What am I doing out here?
Create a new test case. Do you remember what shortcut letter you used to create it?
No.
It's the first letter of the word test.
Oh, okay. At first I was gonna say T, but then I was like, no, because then wouldn't there be other methods that might more?
So now we're going to say test fraction add, I guess. Test fractional add. Add is what I meant to say, ADD.
Sorry.
Remember, control left and right arrows are faster for getting out there. We just hit a couple state keys. Okay, so we need to create 2 super numbers. It might still be on the clipboard, the code to create a new super number. Nope,
Yeah.
that was my bad. I think you have a clipboard history. Control Shift paste. Control Shift V. See that right there?
Yeah.
Let's grab this one right here and hit enter on that guy right there. All right, cool. Now we want to create 2 super numbers, 1 and 2, and add them together. So it's going to be like this. Super number 1, and let's make it be, what do we want to say? Let's do this. This would be a sweet one. If we did 1/3 plus 2/3, right? So we got 1/3 plus 2/3. So we want to say, now we want to say, oh man, I'm going to go crazy. I'm about to go crazy. You're gonna be like, Dad, no. Like that. Super number 3 is equal to super number 1 plus super number 2. Then we're gonna do assert equals 1. This is crazy. We can get this test to pass. All right. Got it? 1/3 plus 2/3. Are we gonna get to be now? Look at what's going on.
Not really. We would get to 1. If we would just get to, I mean, given what we have right now, for
right. But check it out though. If we have this right here, sorry, I bounced on the wrong screen. If we have this, let me show you something. If we have that and we add to it this,
yes, then
hold
we
on.
would just get 0.999.
Right. Our answer is equal to this. And my question is, my theory is, what do you want to bet that Visual Studio or C# compiler converts that to a 1? It rounds it to a 1 when it sees its 9s all the way out to that.
Maybe.
Point. I think it might give us a 1 back.
Actually, that would make sense because that's the highest number a decimal can process, I believe.
That's the most number of digits, yes. Right? That you can sort. Yeah, that's kind of what I'm feeling. Now, notice we cannot add these together. See the red underline here?
Yeah.
These are not numbers. Does that make sense?
Really.
What?
Not really.
Not really. We want to do something called operator overloading. And what's so cool about operator overloading is it allows you to do this and treat these like numbers. So that's what I'm going to do right now. We're going to create, I think I just type in op plus like this, and then in space, and then CodeRush will build that for me. So this is what an operator overload for the plus symbol looks like. It takes in, there's the two super numbers it's taking in right there. We're going to add them together. So what I want to do is I want to create a new super number. I want to return the new super number that's going to have the new whole num and the new numerator.
Yes.
And the new denominator. Do you agree with that? Denominator.
Yes, yeah.
Now, here's the thing. Well, that depends. It depends on the type, right? Look, if SuperNumber.type is equal to numberType.decimal and number 2 is also that one. Here, look, I can select that, shift enter on it. Oops, I meant to change that to 2, and I meant to change this to an and. Okay. If they're both decimals, then it's no big deal. Then we're going to return a new super number, and we're going to pass in one parameter, one piece right here, which is going to be SuperNumber1.value plus what?
Plus SuperNumber2.value.
Exactly. Right, and that's because it's a decimal. But if it's not a decimal, if one of those are not a decimal, or maybe we do this. We just say if either one is a decimal, we change it back to an OR. If either one's a decimal, we're going to get back a decimal. Does that make sense?
Yeah.
But otherwise, they're both fractions. Now we can do fractional math with it. Right?
Yes.
You cool with that? All right, so that's how our logic will be. At this point, we're fractional, so we need to figure out what these guys are. So I'm going to come in here, create a new int right there. That's my new whole number. And my new numerator, and my new denominator, like that. Denominator, I don't think I spelled that anywhere close to right. Name denominator. Okay, cool. So now I've got those three pieces. Basically, I think at this point, it goes like this. We're going to say new denominator is equal to SuperNumber1 dot. Oh, we have to turn it into an improper fraction first, don't we?
Oh, yeah.
Or not? No, we could just add the whole number pieces together.
Really?
Yeah.
We could.
Shirley, are you still hearing an oil drumming sound? I'm not hearing anything like that. Let me know what's going on. Sorry, I missed that. If I came in earlier.
Oh.
I'm not hearing anything.
I kind of can. It's in the music, I believe. Maybe it's just my headphones not being plugged in all the way.
Could be because I had the speakers turned up. Okay.
Yeah, it kind of sounds like a...
Let me know if there's something we should go after here. So we can add the whole numbers. Let's do the whole number piece first. That's the easiest one, right? New whole num is equal to SuperNumber1 dot whole number plus SuperNumber2 dot whole number.
Yeah.
Right? Agree?
Yeah.
Okay. New denominator is equal to SuperNumber1 dot denominator times SuperNumber 2 dot denominator. Do you agree with this? Do you understand what my strategy is here?
Yes.
You do?
Yes.
Okay, so then...
Wait, why? Why times when in the whole...
Well, because this might be a third and this might be a half. And if I multiply them, I know I'll get to a sixth, and I know I can definitely add in sixth.
Oh, okay.
Right? And then that means my new numerator, this one's harder to figure out, but it's basically equal to SuperNumber 1 dot numerator times something.
SuperNumber 2 dot home number, or?
Plus SuperNumber 2 dot denominator plus SuperNumber 2 dot numerator times SuperNumber 1 dot denominator. Pretty sure that's right.
Okay.
Like that.
Okay.
That's what I think is right. Now, the problem is this is going to be a totally improper fraction.
Oh,
It's
yeah.
going to be all messed up. So what we really need is to maybe come in here and we need a method that says make proper.
Yeah.
Where it simplifies the fraction, right? Which we don't really have yet. So right now what I'm going to do is I'm just going to have, wait, let's not do it here. Instead, let's create this as a new local, and we'll make a call on it. We'll call this answer, like this, and then we're going to say answer.makeProper. So right now we're going to have make proper is not going to work. Okay, it's going to do nothing right now. We're going to attack that problem separately. Okay, so make proper does nothing. Maybe make it. Let's rename it to make fraction proper. Like that. Okay, but we do have an add now, which means we can come over here to our test case. We can actually try running this and see what we get. Let's give it a shot.
Okay.
It totally passed.
It worked.
Okay, good. Test fractional add, good. That's good. The test fractional add worked. It rounded up. 1/3 plus 2/3 is equal to 1. That is awesome. Let's start having creating some problems here. There's something else we can do too. See this called a value here?
Yeah.
There's something called implicit conversion. I forget how to do implicit conversion. Let's go look over to my machine here. Switch over to my machine for a second. Implicit means it kind of does it on its own. Does that make sense?
Yeah.
Implicit and conversion means it converts it from a SuperNumber to a number. What I want to do is I want to have an implicit conversion. Let's add the language C# here, so we can see how to do it in C#. User-defined conversion operators. Static implicit operator. This is what it looks like here. Sweet. That's sweet. All right, cool. Let's see if we can do this. This would be so awesome because it simplifies our code. So we're gonna put a comment here that says implicit conversion. So we remember this, how to do this. Implicit conversion to a decimal. And so instead of having the word byte here, we're gonna have decimal. So typing TDE there. Then it's gonna take in a SuperNumber, I think. And then it's going to return what property from SuperNumber?
Oh, wait, we're not on.
Oh, sorry. Thanks, my friend. So here's what I've got. This converts a SuperNumber to a decimal. What are we going to take?
Value, correct.
Value. So now that we've done that, what that does in our unit test is look at this. we can get rid of that and now treat SuperNumber as a real number. Does that make sense?
Yeah.
So now I can add SuperNumbers together, and I can see what their values are. This is awesome, by the way. I love that rounded to a 1.
The sound is gone.
What's gone?
The sound before.
Oh,
That's
sound that you heard before? Okay, cool.
Got
Oh, Shirley says there's someone banging a desk or bouncing the chair against a wall. Oh, that might have been Campbell.
Oh, okay, yeah.
That might have been Campbell. All right, so look what happens here. See this? Right here?
Yeah?
I can do that now. See what happens because of that? It's just implicitly converting it. Now we come in here, we run all the test cases. We can run them all by doing this, run all the tests. It should all pass. Sweet, we got implicit conversion. That's awesome. Okay, cool. So now I'm loving this. I'm loving it. Next, we want to break this. We want to create an ad that breaks. Okay, so I'm going to come down here, add improper, I think is what I'm going to call it. And so what I'm going to do down here is I'm going to say 1/3 plus 2/6. Let's see if this one works. Or not 2/6. Is that right? 2/6? Yeah. So 1/3 plus 2/6 is really 1/3 plus 1/3, which is 2/3, right?
Yeah.
And so what we want to do is check to see if these two are equal, 2/3 and SuperNumber 3. Does that make sense?
Yeah.
Okay, that's what I want to do. And it's going to be false if we run this. It's going to come back and say, if we use this as our strategy, it should come back and say, well, 3 times 6, it should be over 18. So it should be 6 plus, looks like 6 again, should be 12/18 is what it's going to come back with. So say 12/18 is not equal. Yeah, expected, well, it's not telling us the details of it. I wonder if we can get this with a, let's see one other thing. There's a way, I wonder if we can change this. It's called hold on a second. Debugger attributes, C#. I'm working on my machine for debugger attributes. Debugger display attributes, that's what I'm looking for. Is there a way to do conditional stuff with here? There's not, but you know what I'm going to do is this. I'm going to come in here, I'm going to create a property that says debugger display, back over to your machine, debugger display attribute, and I'm going to say it's value as stir like this. I'm going to use a property called value as stir, which I'm going to create and put my conditional logic in. So I'll come down here, put a read-only string property, value as stir, and let's create my getter right here. And now I want to check to see, hey, if type is equal, pay attention because I'm going to ask you to switch over here in a second. If type is equal to number type decimal, then I'm going to return my value, called toString on it. Okay? But if it's not a decimal, I want to return something else. And I'll give you a hint, it's an interpolated string that's going to look like 1 1/2 or 2/3 or something like that. See that?
Oh, yeah, okay.
Build that for me.
Oops.
It's the other one.
Yeah.
There we go.
Right?
Yep,
Yeah.
that looks really good. All right, now let's try running that. I want to see what, the whole reason I did that is I want to see if we can get better data from the test run, because it was saying what the value, it was expecting whole, SuperNumber, but got SuperNumber.
Oh yeah.
Remember that? I want to see if that's going to change this. If the debugger display attribute will change the output. I'm hoping it will. So go back and run that test again. Unit test.
This one or this one, right?
The one that failed, yeah.
Huh, the drones are frozen.
Nope, it did not give us better values. It's too bad. Okay, so the problem is, so notice this. This is, sorry, here. 2/3 it doesn't get. But what do you want to bet that it does get 12/18? I bet it gets 12/18. I bet this line passes, this one fails.
Well, why wouldn't it work with... Okay.
Whoa, it didn't even get 12/18.
Yeah, because it's still turning it into the decimal that is 0.3333.
No, because its type is a fraction. These are both fractions. Let's set a breakpoint. Let's see if we can debug this test. We had problems trying to debug before. Let's see if we can get this to work. Sweet. All right, let's look at SuperNumber 3. Well, look at it. It's 0 and 12/18. See it?
Yeah, but wow.
So why wouldn't this work? Why would that one fail? I don't get that at all. Yeah, it's a fraction. Let's do this. Let's go look at, if we go into SuperNumber, what do we have? Oh, I know what. We don't have an operator for the implicit equals yet. So we need to make this work. It's checking to see if these two are equal, but we need to have an override for the equals operator. So we've built an override. Here's what we've done. We've overridden the plus. We've overridden the implicit conversion. We created implicit conversion to decimal. Now we need to create an op double equals, which is for our tests, like this. We slightly change this code that's generated here. We're going to create that instead. SuperNumber, so we've got left and rights on the SuperNumber, and we need an equals method over here. Oh, we do have an equals number. What's wrong here though? Is it just that it's ambiguous? The two SuperNumber equals, that's probably what I have. I have two, I don't need one. Okay. Okay. That fixed some of those errors. All right, so a lot of, when I do the op equals, it builds a lot of code for me, right? There's a lot of stuff that we need to do here. Notice that we also have to create a not equals, which basically says the not equals operator is going to be left as rather not equal to each other. Get hash code, I'm fine with that as is for now. Here's my equals. Finally, we get out here and calling equals right up here. I'm going to call this SuperNumber. And then what we're going to do is compare some of the pieces in here. We're going to say, hey, look, if the type that we're in, remember, this is a method. This is a method of the instance. So I can call type right there. If type is equal to SuperNumber.type, so if they're both equal, and they're both fractions, and the type is equal to numberType.fractions, then we want to compare the whole number. Then we want to basically say, hey, look, the whole number is equal to the SuperNumber.whole number, and the numerator is equal to the SuperNumber.numerator, and the denominator is equal to the SuperNumber.denominator. So if, oops, I'm going to double equals right here. If the two types are equal and they're both a fraction, or maybe a better way of saying it, easier to read way of saying it is, if they're both fractions, like this. If type is equal to fraction and SuperNumber type is equal to fraction, then that's how we do it. Otherwise, we're going to say, hey, return value is equal to what? What's the test here that we're going to return? It's similar to the logic here, but we're not comparing fractions, we're comparing the decimal.
Right. So, I'm not sure actually then.
It's going to be SuperNumber, this parameter we're passing in, because that's what we're testing in the equals. SuperNumber dot something.
Dot
value. That's what it is right there. So, okay, so that is our equals now. Now with that, let's go back to the unit test, and I think I'm now predicting this will be true and that will be false. And that's what I'm looking for right now. So let's run the test. And I think we're gonna fail there. Yeah, see, we get the fail here, but not there. That's just our breakpoint. So this line passes, this line fails. Okay?
Yes.
Now, we could do this too. We could come in, one of the things we could do in our equals is, instead of doing this, because 2/3 is the same as 4/6, right?
Yeah.
Oh, I got a message from Shirley Dev. Shirley Dev was trying to control the pages and it didn't get a switch. Why didn't you get it? I just got it. Interesting. The mark didn't work for Shirley Dev. Let me try to just mark all by itself. Okay, maybe that's what you need to do, Shirley. Shirley says, what Campbell's doing right now, because something is sounding awful with the mic setup as it is. I can't see everything on cam that might be giving it away. Is he tapping his feet on the desk legs or something? The audio setup on these KC episodes is a little rough sometimes. So do you hear that, Campbell? All right, thanks, Shirley. Thanks, Shirley. We will be careful on that. We will be careful. Yeah. Okay. So I just said 2/3 is equal to 4/6. Do you see that in your head?
Yeah.
Well, we're looking to see if the numbers are the same, but not if they're actually equivalent. Does that make sense?
Yes.
So what we might want to do instead is we might want to figure something else out in terms of making them equivalent. Like we could have a check like this that says, hey, return is equivalent, our fractions equivalent. Maybe like that is the method name. Our fractions equivalent. And we'll pass in SuperNumber. Like that. And what's cool about this is we can just simply, for now, return this, but later we want to actually improve this and make it better. So, like, see what I'm saying?
Yeah.
On that. So right now it's just going to do the same thing, but we kind of need a test case that fails here too. So we've kind of got that here, but let's create a new test case that's going to fail. And there's actually, so test equivalent fractions. And I'll just write this real quickly. We're going to, I'm going to grab this. We'll grab both of these, like this. And so create two equivalent fractions. We'll make this one be 2/3 and this one be 4/6. You agree those are both equivalent?
Yeah.
So then I'm going to come in here and I'm going to say SuperNumber1 dot our fractions equivalent to SuperNumber2. I don't know if I like that method name that much. But now what I want to do is say, I want to call AT assert true that they're both equivalent. And this should now fail. Even though you and I know that they're equivalent.
Yes.
Can you imagine what the value is of a failing test case? Why was I so enthusiastic about getting a failing test case here?
So that we knew what the limits of our code were, and also just to test out what we could do and what we couldn't. So
sure, and it's also like serves as a benchmark. It's like setting a goal.
Yeah.
My goal is I want the test case to pass. the value of having it fail is actually incredibly high right now. Because now if I
better
ever go
than
to,
just having it pass immediately.
yeah, and the thing is, the cool thing about this test case is I don't have to, Surly says, no worries, it's a bit hard because of the echoey room mic picking up all the background noise. I may be, I've got Kemal's mic turned up a little louder than I need to too. Let me turn it down a little bit, see if that's any better. After the show, I think I'll go in and listen to the show and we'll see how it sounds. See if we can figure out what's going on. Okay, so do we want to work on, so right now we've got two essentially failing problems. Our addition works, right? But our make proper doesn't work, right? We don't have a way to make them proper.
Yeah.
Right? There's another test method I want to create, and it's the make proper one. Test make proper. Fraction. And I want to have that look kind of like, let's just do this. We're going to R equals, insert equal, 2 and 3 with SuperNumber. That's what I want. This is going to fail. Well, actually, that's okay to fail, but what I want is when I call make fraction proper, right? I want this to pass. Well, I want them both to pass, right? But I'm expecting it to fail right down here.
Yeah.
That's what I'm expecting it to fail. In fact, that's exactly where it failed. It looks like I hit a shortcut to do them. And so it's failing right there. Okay, so make fraction proper is not working. What do we want to do? I'm not really sure if we want to tackle this or not. Make fraction proper. Because I'm not sure how to make a fraction proper. Do you remember how to do it? What are the guidelines?
Yeah, it's I remember that. Oh, no, never mind. I don't remember anything useful about it for making it proper. Making an improper fraction proper. Unless.
Well, if both the top number, both the numerator and the denominator are divisible by the same prime, then we can divide them both by the same prime and it has no impact on the value.
Yeah, but that wouldn't make it proper, would it?
Well, it gets it closer. We still have to deal with the whole number, right? So if the numerator is greater than the denominator, then we remove that and add it to the whole number. I think we can do it. We had a code last time that found primes. Remember this? We did something last time.
No, I don't.
We found the factors.
Oh, yes.
Remember that?
Yes,
we found the factors. Can you open that project? That code is actually really valuable to us right now. Right? Finding the factors. We find the factors for two different numbers. We find out which ones are common and we divide by those ones that are common. It's a brilliant, brilliant way to do this. Find factors. It was its own package out here, right?
I think so.
Can I open it up and look at it? Look inside. Factor test math library. Here's our math library. Got something called SuperMath. Is factor. Get factors. That's what we need. You know what? I'm not supposed to do this, Campbell, but I'm going to do it, I think. I'm going to take this guy and I'm going to copy it and I'm going to paste it into. You really shouldn't do this. Don't ever do this in real life, kids. But I'm going to take it and I'm going to put it. Yeah, I'm going to put it over inside of here. Or not. Maybe I'll take the whole.
Isn't that?
Is it what?
Never mind. I was thinking, isn't that what made all of the consequences beforehand?
No, it was with I was doing it with the project is what I was doing that with. Yeah, so the problem here is that, or maybe we'll do this. You know, we'll do this. This is the better way to do it. I'm going to choose add existing project. I'm going to go out and find the math library that we created before, which is right in here, in this path. It's way off base. And what the problem with this is once I do this, is that this project won't compile for people that download it because they won't have it in the same folder.
Yeah.
If I copy it over, it will. That's the reason why I'm thinking this. Yeah, you know, I'm back to copying this over. It's kind of what I'm back to doing here. Yeah. I'm going to copy it over. I have a great solution to this. Anyway, let's see. I was in add existing project. I don't need to do that anymore. SuperCalc core, we're going to say add existing item. And I'm going to, whoops, I thought I had it on the clipboard. Copy that file, paste that file in here, SuperMath. I'm going to do that. And so now we've got SuperMath in here. And SuperMath has got this awesome get factors.
Yeah.
Okay, so now what we can do is we can, let's go to make fraction proper. So now what we need to do is call, let's go to SuperMath. Let's change its core is what we're calling this. Do that right there. And now we're going to say, so math library, SuperMath, dot get factors. So we're going to get the factors for the numerator.
Yeah. And then
we're just going to take this a piece at a time. So we're going to get these first, then we're going to get our denominator pieces. You with me so far?
yes.
Now we will essentially want to find the union of these two lists. So here's what I'm going to do. I'm going to create something new that's going to say common factors. I'm going to create a method called getUnion. And I think I'm going to put it in SuperMath actually. And I'm going to pass in both of these. So what it's going to do is it's going to create a new list of all the common factors. Does that make sense?
Yes.
Okay, cool. So now I've got this really powerful thing, getUnion, that I can call all over the place. Let's go build that. Now let's give these better names. So getUnion, this one down here will be list 1, and this one we call list 2. Like that. And then what I want to do is, I don't think there's anything built in to get a union between two lists of the same values. But maybe there is. Maybe it's worth a search. Let's try it. C# generic lists get union. See if there's anything out here. I want to get rid of duplicates. I don't want to get rid of duplicates. That's definitely not what I want to do. Union to list of objects. Ooh, there's a union is a member of list, but is extension by enumerable. Oh, sweet. That might already be here. That may be really useful. So we're going to say return list1 dot union. Sweet. Is this going to work for us? List 2. We want to definitely break through, step into that. And then call toList on that. So what that gets us is not quite a list. Oh my gosh, would that be so awesome?
Oh.
If we didn't have to write this code. Oops, sorry, wrong machine. Is that what you're saying?
Yeah.
Thanks, buddy. Okay, now we get our common factors. Now what we want to do is what? So say my common factors with 2. I only have 1 in there. I'm going to start with a for each loop right there. Okay, for each common factor, what am I going to do with my numerator for each common factor?
I'm not sure.
Oh man. Yeah, it is. It's kind of like a little mind-blowing, isn't it? So we're going to do a divide equals by the factor. Right, well, it's so much easier if we just think about this in terms of, you ever get this, I'm not sure, it's so much easier to say, what if I had an example, right? So in the example, let's say that my numerator was 4.
Genescu 7, where are you? We need your help. Oh, alright.
Fractions, factors.
Here. Oh, I am.
All right.
Hi, Genescu 7.
Hey, Genescu 7, welcome. So my numerator is 4, my denominator was 6. I would get in my common factors, would look like this. It just have a single number 2 in it.
Oh, yeah.
Right, because this is 2 times 2,
And that is...
and this was 2 times 3. So what do I do now for each common factor I found? So for the number 2, what do I do to both of those with the number 2?
Oh,
I take the number, which was 4, and I divide it by 2.
Oh, and then we get the other...
Which means the numerator will now be 2.
Okay.
And then I do the same thing with the denominator, divided by the common factor, which will now turn it into a 3.
Yeah.
You see what's going on there?
Yes.
That's what's happening. So we're getting that list, right? Getting the list of the common factors. If this was something bigger, like 2 times 2 times 2, which was 8, right? See that? And
Yeah.
this was 12, if it was 8 twelfths, that would be 2 times 2 times 3. Our common factors would be 2 and 2. If the union does this right, we really need to check to make sure union works the way we expect it to. If it does, we do each one of those. We're not quite done, but it's enough to do a test. So let's do a test. Let's get a test for 8 twelfths and see if we can get 8 twelfths and turn it into 2/3. That's what I'm looking for. So test proper fraction. There's one of these. And let's do a second one here that we're going to do 8 twelfths. And we want to get that, after called make fraction proper, into 2/3. Does that make sense?
Yeah.
That's what we're looking for. And we want to see where we pass or fail. Actually, I want to take all of this and I want to put this in its own test method. Let's do this. Let's take this, duplicate this, and we're going to call this number 2. And there's my 8 twelfths. And just declare the type. Okay? So now let's test this one. This one I expect to, maybe, is this going to pass? If this passes, that means the union is doing exactly what we want.
Yeah.
And it looks like it fails. It doesn't quite tell us what these pieces are. I'm not liking this part here. In fact, you know what? I want to report a code rush issue. So I actually want to fix this. So I want code rush to be better at. Okay, devs, take a look at this. We are doing it. We've got we're comparing 2 different super numbers. So the dev says, "Hi devs, over there. We're comparing this super number with this super number. And look at what happens in the test runner. It says expected this value, but was that value. Our super number has a debugger display attribute, which is designed to reveal what its value is, but it's not putting that out there. And so I really think we should use the debugger display attribute if it has one, so that we can show what we found, right? So we can see what the differences are. That's the bug. That's what I want you guys to fix in the test runner there. Use the debugger display attribute in the test runner output. Okay, let me put that in the chat room. Boom, that takes the issue back out there. It looks like I included the log. This is on somebody else's machine, so there's no log here. But the source code for this, let's get the source code for this. Can we get that up on GitHub still? Is this it right here? It's going to be here. By the end of the show, we'll check that in, and you'll be able to get it. I just pasted it into the chat room there, so you should be able to get that as you watch it. Okay, Campbell, back to you.
Okay.
Let's see, making the fraction improper and proper, that sort of thing. So we want to do it, we want to step into it, is what I think we want to do. R equal 2/3, this should be true. I'm worried that the union doesn't do what we want, we're going to have to write it ourselves. Let's set a breakpoint here and we'll step into the code. We'll debug the test. Let's just look at it. Whoa, 1/2? You see that?
Yeah.
That's not what I'm expecting. We got a problem. We need to come back up here and come back down in here and now look at what's going on inside here. What is our code? So my numerator factors, I got 3 of them. And they are 2, 2, and 2 for 8. Makes sense. Denominator factors. I got 2, 2, and 3, right? Just like we have up here. Common factors. What's coming back from here? 2 of them. 2 and 3. What? Union totally didn't work. Union didn't give us what was common from the 2. Oh, is it because I'm using union? Yes. Okay, my bad. I don't want to use union. I want to use, it's not, I've been using the wrong word. I want to use, like, it's intersection, I think.
Oh, right.
Intersection or common? Is it better to say common? Yeah, intersection is what
we wrote it down somewhere in a Google slide what each of them did.
All right, so my bad. I got to this on the wrong path here. Let's see, do we have intersection? Intersect. All right, let's see what happens here with this. Let's set a breakpoint here. Let's go back to unit tests. Saving everything, let's debug it. I'm just gonna run, we got another breakpoint in here. Here's the intersect. So we have list 1, we've already seen 2, 2, and 2. List 2 has got 2, 2, and 3.
Yay.
So we're expecting to just get, we want 2 of these back.
So far,
let's get out of here and see what we've got back here. Just 1.
Just as it was.
2. Intersect doesn't work either because it sees the multiples. Okay, we need to create our own method. All right.
Wait, I don't think we do. Can you go back to the, I think it was in just the regular KidzCode slide for Microsoft.
You want my slide?
PowerPoint, yes.
Sure.
I remember we wrote it down somewhere.
What did we write down?
Oh, no. What each of them did.
Yeah. We were talking about, what were we talking about? We were talking about shapes and things like that. Yeah, it's not quite here. I'm pretty sure it's not in this space. My memory is telling me that's not the case. I think we're gonna have to write our own. I don't think we do because I remember there being something like what we want right now, but I'm not sure what it's called, and I believe we wrote it down there. Well, I'm not remembering, so here's what I'm going to do. I'm going to come in here and I'm going to say answer, like this. Here's what I'm going to do. And I'm going to say answer is equal to new list of that, of this. Then I think I'm going to go through every element in here. That's my gut feel. So go through every number in list 1. Then I want to say, hey, if list 2 2.contains number, then I want to do two things. I want to remove it.
Yeah.
Yeah, removes the first occurrence. That's what I want. See that? First occurrence. So I'm going to remove the number and I'm going to add it somewhere else to answer. See that? We come down here and say answer.add the number. Does that make sense?
Yeah.
So for each one in the list, so if this is 2, 2, and 2, the first time I see it, I'm going to say, does list 2 contain it? Yeah, it does. Then remove it from list 2 and add it to here. The reason I remove it is because the next time I come in, I don't want the same one at the front to make it seem like there's a whole bunch of them in there. So I have to remove it from that list, is what I have to do. And then I can come here at the end and do that and add it. The only thing I want to do here put a clone method in here. I think I can do this. New list int pass in that list too. I want to clone it is what I want to do, and I want to work on the clone instead, because if I go in and remove it from here, then it'll remove it from whatever one I passed in, and I don't want to change anything from the outside. Does that make sense? If you tell me to do something, I don't want to change you. I don't want the method to reach outside of it. And now all of a sudden you've asked me to wash the dishes, and now I've turned you into a clone with, flying abilities, things like that. I don't want to change you. Okay, makes sense? So I'm going to clone it like that. I believe that's going to work. Let's try and let's rename this to get common, like that. I think we'll do that. All right, one more time, big breakpoint here. Back over to our tests, and let's run the test. Didn't work. Let's debug the test so we see our breakpoints. Run it here. What do we get? Only one. Why did that fail? Let's go back inside there. All right, we've got 3 and 3 coming in. 2, 2, 2. And what do you expect here? 2, 2, and 3. Right? This is my 12, that's my 8. Right? 2 times 2 times 2. You follow that? You know I have those there? All right, let's go do this. Do that for each number inside of here. There's my first one. Does list 2 clone contain it? And if it does, so if list 2 clone is 2, 2, 3, then we're going to remove it from the 2 clone. And, oh, I see what my problem is. The problem isn't here. Look what I'm returning. I'm returning the same old code. I want to return an answer instead. You see it? I just didn't change that. All right, let's do a set of breakpoint here, make sure answer's right. You get down here. Answer's now 2, 2, and 2. That's what I'm talking about. That's what we're trying to get to. Okay, so if we keep going, I hit run. Back over to unit test. Did it pass? It did. See it? So now we're making a proper. See it?
Yeah.
Okay. Let's change this. Okay, that's a good one. Right there. Let's duplicate this whole thing. This is 3. And now I'm going to come in and I'm going to say, let's take, let's do 8 thirds. Make fraction proper. What should this be as a proper fraction?
Oh. I'm not sure.
What if it's 4 thirds? What's proper fraction of 4 thirds? Hint, this number changes.
Oh. I'm still not quite.
Well, isn't 4 thirds an improper fraction? Shouldn't it be 1 1/3?
Oh, that's
Or
true.
not?
Yeah.
Okay, so let's make it 1 1/3. Right there. By the way, certainly that massive explosion you do, that's also something you could do to get my attention if the other ones wasn't working. Okay, so I want that to be 1 1/3. Let's try it. It's failing. Okay, it's not 1 1/3, it's not matching up. So we got to go back to make fraction proper. We got to finish that up. That's what we have to do. So the problem is what here? How would you describe this problem? 4/3 does not become this. What's the problem? How would we identify an improper fraction?
The numerator is bigger than the denominator.
The numerator is bigger than the denominator. So here's what we do. We're going to first come in here. We're going to get the common factors, divide everything by them. That's going to simplify. That's going to simplify both the numerator and the denominator. Next, we need to check to say, hey, if the numerator is greater than the denominator, then we need to do something. We basically need to see what the impact is on the whole number. So it basically looks something like this: whole number plus equals, and we want to cast this as an int, the numerator divided by the denominator, with actually essentially almost these both cast as int as well, like that. So that right there, if we cast these all as ints, at least these two, we actually don't need to cast the outside one, because if we cast the inside, the result will be an int. Right? Well, isn't a numerator an int already? It is. I don't need to cast at all. In fact, Visual Studio is telling me that. What'd you say?
And same with the denominator.
Yeah. Okay. So whole number is equal to numerator divided by denominator plus equals. So if the numerator is 4 and denominator is 3, 4 divided by 3 is 1 as an int.
Yeah.
Okay. Then we want to say numerator, well, maybe let's do this instead. Let's create a new int here. Call it offset. And we're going to set that equal to this. Okay? We're going to do whole plus equals on offset. The reason I store it is because I need to modify numerator. I then need to say numerator minus equals the offset. Okay, so let's look at the logic here. Let's actually step right through it. We set a breakpoint here. We'll step through it, see if the logic works. Okay, so we'll come back here to our failing test. We'll debug the test and see what happens. So now we're down here, and we've got numerators 4, denominators 3.
Yeah.
So offset is 1.
Yes.
4 divided by 3 is 1 and something. So we're going to say whole number plus equals the offset. And then we're going to say numerator, oh, it's not this. It's not offset. It's offset times my denominator.
Oh,
right?
yeah.
Because it's in thirds or fourths or whatever, right? Right, like that. Right? It's, if I add a whole number here, that's the same as this many denominators. So I have to multiply by the denominator right there. So my numerator is 4, my denominator is 3, so I'm going to subtract 3 from my numerator, turning it into a 1. So 4/3 becomes 1 and 1/3. See how the whole number is now up at 1? And numerator is going to now drop down to 1. And I think that's correct. And now the test case should pass. There it is. See, it passes now. Which means our other test cases should also pass. These should pass as well. This one should now fail. See this one?
Yeah.
Oh no, wait, maybe this is still good. This one was still good too, I think. Let's run them all. Let's run all our test cases. So I'm just going to go up to the test class, click on this and say run. Whoops. Run all those tests. Got 2 fails. This one, I think we can get rid of this. Does our add make it proper? I think we have a call to make proper in our add. Here's our operator plus. See that right there?
Yeah.
Yeah, see it? There's the call to make a fraction proper. So this code here, that it used to be this passed and this failed. Now with our new fix, we have this.
Yeah.
In fact, we can make this an even harder test by changing this to a 4, right? And since it's over thirds, right, then this should become a 1 2/3, I think. Let's try that. 4/3 plus 2/6. Look at that, it passes. Sweet. All right, let's go do all the tests again. See, I think there's one more test failing. Just equivalent fractions. Okay. This, if we call make fraction proper, now this should work. Or actually, better, are equivalent fractions equivalent? Let's go do that in there. So here, what I want to do though is I don't want to change. I want to clone two different things and compare the two clone things. Is what I want to do. So yeah. I want to say, because I don't want to change my current one. So we'll call it this SuperNumber is equal to this dot, and I'm going to call clone. Not number-wise clone. We don't have it yet, but we'll create it. Then I'm going to say compare number is equal to SuperNumber dot clone as well. Just jumping in with that number-wise clone. It wants to give me. This is also SuperNumber. Then I want to say return, and then I want to basically on both of those, I want to say make fractions proper, right there, and on compare number as well. Oops. Let's close it down so we see more code. Do the same thing down here. Okay. Then I want to go down here and I want to work on that one and on this one right here. So again, I'm cloning. This is this process of, hey, you pass in something to me, I'm not going to mess with it, right? I'm going to instead make a copy of it, and then we're going to mess with the copy. So I'm going to return a new SuperNumber like this. I want to check to see, hey, if this dot type is equal to number type dot decimal, then I'm going to return a new SuperNumber passing in this dot what?
Value. Perfect.
That's exactly what I'm going to do. Otherwise, I'm going to return a new SuperNumber passing in this dot, what is it, whole number, comma this dot numerator, comma this dot denominator. All right?
Yeah.
All right, cool. That's my clone. Now our fraction, I think that's all I need to do. Let's go over here and run the failing test case. See if it works. I really want it to work. Sweet. So now we've got all of our test cases should be passing. Let's run it one more time. Sweet, 7 test cases passed. That's awesome, Campbell. Also, we're like, essentially at the end of the show. So I think this is pretty good, right? We've got some high quality test cases here, right? We have the ability to add fractions. We have the ability to treat a number as a fraction or as a decimal. We don't have any units yet.
No.
We'll come back tomorrow, we'll add units. Maybe we'll add an operator for subtraction, so we can do subtraction. Again, the cool thing about the operator is now, instead of having to call a method to add things together, I just do the plus out there.
Yeah.
And that's the cool thing about C# is it allows you to overload the operators. So I could even have like one string plus another string, or one address plus another address, and we create a list of addresses or something like that.
Yeah.
Right? You can do whatever you want to do there. Like you can create a set element and add things to a set just with the plus operator if you want to, or any other operator. There's like, I think about 30 operators you can overload. So pretty cool.
Yeah.
All right. So tomorrow we'll pick this up and we'll complete this. Thanks everybody for joining us. I'll get a raid going up there. Can you check in this code, Campbell, on your side while I work on that raid?
So
All right, well, Camel does that. We'll check that in a second. I'm going to go ahead and start the raid. We're going to send you over to KidzCode.
Okay.
And we will see you
Tomorrow.
tomorrow, kids.
See you
Thanks again so
tomorrow.
much.
Mystery deck doesn't work. Okay.